Hi, my name is Ryan.
And my name's Michael.
And I'm John. Today we're going to talk to you about bonds. James bonds. Just kidding. We're going to talk about molecular bonds.
So there are four types of bonds. There's ionic, covalent, metallic, and polar.
In our first demonstration, we're going to show you metallic bonds and some of their properties.
In this demonstration, we have stress test analyzer to determine the strength of different metals. First, we test aluminum. The stress test tells us that it took 238 pounds of force to break. Secondly, we test steel. Steel is composed of predominantly iron with carbon, manganese, phosphorus, sulfur, and silicon. This test shows us that it took 327 pounds to break.
Wow, that was fun. What did you say, Ryan?
Yeah, it was. It really demonstrated the strength and malleability of the metallic bond.
In our next demonstration, we'll discuss ionic bonds and some of their properties.
Alright, so in this demonstration, we measure the conductivity of three different solutions. We have deionized water on the left, salt water in the middle, and sugar water on the right. First, we measure the conductivity of the deionized water on the left. This served as the baseline for this demonstration, and as you can see, it's 134 microsiemens per centimeter. Then we rinsed the probe off with deionized water, and as we put it into the salt water, you can see in the top right that the conductivity increased greatly over the deionized water. This is because of the ionic bonds in salt. It allows the salt to become aqueous and ultimately increases the conductivity of the solution. Now we rinsed the conductivity probe again with deionized water and stuck it into the sugar solution. And as you can see, the sugar solution, sugar which is a covalent compound, the conductivity is the exact same as the deionized water on the left.
Wow, that was a really clear demonstration.
Yeah, it really showed how ionic compounds can conduct electricity in aqueous solutions, while covalent compounds don't.
In our next demonstration, we'll talk about the melting points of some of these molecular bonds.
This demonstration shows the melting and boiling point of ice and water. Ice and water have two totally different structures. The salt has ionic bonds in a crystalline structure, which both take a lot of energy to break. The water has hydrogen bonding, and for its structure, it's very strong, but compared to the ionic bond, like in salt, it has a relatively low melting or boiling point.
Alright, so in review, metallic compounds are conductive due to their protons and sea of electrons. When an electrical current hits the metallic compounds, the sea of electrons allows the current to flow through the compound. And due to the sea of electrons, it's also malleable but strong, so it can be bendable but it can't break. And it also gives it a high melting point.
Okay. Ionic bonds, they have a relatively high melting point. They're conductive in aqueous solutions. An example of one of them is salt.
Alright, so polar bonds occur when there's a difference in electronegativity, like O and H, because they're far apart in the periodic table. There's a difference in electronegativity. And polar bonds can cause molecules to be polar, but not always, so be careful. One example of a polar molecule is H2O, with a bent structure.
Covalent bonds are chemical bonds involving the sharing of two electrons or more. It's used to fill the outer shell of the electrons so that becomes less reactive. An example of this is H2. It's when one hydrogen atom and another hydrogen atom, each having one electron in its outer shell, combine and having two outer electrons, which is its outermost shell, creating H2.